So in this video, we'll look at a simple problem which relies on the use of the differentiation of a function f of x. And please look at the current picture. You're given the graph of a function f of x. And I'm asking you to find the equation of a tangent. And let's look at a concrete example. So please look at this problem. The function is y equals x cubed plus 2x plus 1. The graph is not given, but it doesn't matter. I'm just asking you to find the equation of tangent at x equals 1. And please notice the fact that to write down the equation of tangent, usually you need two pieces of information. Like the point is good, and on top of that, if you know the slope, let's say the slope at this point is m. If you have these two pieces of information, the equation of the tangent is the same as y minus y1 equals m open bracket x minus x1. It's a standard formula. Some people call it the point-slope form of a straight line. You need one point and one slope. And let's look at the current problem now. What is the point? The point we have when x is 1, y is the same as the right-hand side by replacing x by 1. So 1 cubed plus 2 times 1 plus 1, which is 4. So it means the point we have now is 1, 4. The y coordinate is 4. And what is the slope? And the slope, we can actually make use of the derivative because derivative of a function actually capture the slope at that particular point if you evaluate it at the point x equals x naught. So let's look at the derivative first. Derivative of the function, which is 3x squared plus 2. And because now I look at the x value as 1. So f prime of 1 is the same as 3 times 1 plus 2, which is 5. So I have a slope value, which is 5, and the point is 1, 4. So the equation of tangent is y minus 4 is the left-hand side, and the right-hand side is 5, which is the slope, open bracket x minus the x coordinate, which is 1. So that's basically the equation of tangent. So next, let's look at this problem. I'm not giving you the graph as a y equals function of x form, and it is not like this. I'm giving you kind of an implicit equation that connects the two variables y and x together by an equation here, and I'm asking you to find the equation of tangent at the point 1, 1. And now it is clear that the point is already given, which is 1, 1. And let's see how to find the slope. And mathematically, slope is the same as finding y prime first. And how to find y prime? It is a problem about implicit differentiations. We can differentiate both with respect to x for the equation xy plus y squared equals 2. And after differentiation, the right-hand side is 0, right? How about the left-hand side? The first term x times y is a product. So it becomes 1 times y plus x times, you see, if you differentiate y with respect to y, it becomes 1. And but because we are differentiating with respect to x, there's a y prime coming out. So the better way is to write it as x times y prime. And the next y squared becomes 2y if you differentiate it with respect to y, but because we are doing differentiation for the variable x, there's a y prime coming out. It's a chain rule application. So y plus x times y prime plus 2y times y prime equals 0. And now, please check the fact that I care about the value of the y prime, which is the slope, at the points 1 and 1. And I can directly replace x equals 1, y equals 1 into the equation. So y becomes 1 plus 1 times y prime plus 2 times 1 times y prime equals 0. So let's find the y prime together. So y prime becomes 1 plus y prime plus 2y prime equals 0. So 1 plus 3y prime equals 0. So y prime is the same as minus 1 over 3. So this one is the slope we want. And now the equation of tangents is easy because you know the point is 1, 1, and you know the slope is minus 1 over 3. So equation of tangents It's gonna be y minus 1 for the left-hand side equals minus 1 over 3, which is the slope, times x minus 1. So that's the final answer to this problem.